Hi friends, welcome to another episode of Decluttered. In today's episode, we will look at some challenging and interesting JEE level problems that I came across when I was working with my students. Now, these questions that I came across are from this magazine, Mathematical Spectrum by Arihant Publications, and this is from the time when I was preparing for JEE, that is back in 2008. So, this is the magazine that I had a subscription to when I was preparing for JEE for some difficult, interesting, and conceptual questions. Let's dive into some questions from the magazine. So the first question is that if summation of TR, where TR represents the rth term of a sequence, is given by n into n plus 1 into n plus 2 into n plus 3 by 8, then the question is what is limit n tending to infinity 1 by TR and the summation of that. The first thoughts that come to my mind is that this has to be, as it's a limit question, I should probably get an inverse or a geometric progression, maybe, maybe not. Let's try and see where this gets us, right? Let me define the term Sn as summation TR, which is n into n plus 1 into n plus 2 into n plus 3 by 8. Now, I'm going to define Sn minus 1 because it's for Sn, I can take the summation from R1 to n minus 1 as summation TR till n minus 1 as n minus 1, n plus 1, n plus 2 by 8 by simply replacing n with n minus 1. And it is for us to understand that Sn is actually Tn plus Sn minus 1. So if I subtract Sn minus 1 from Sn, I will get the nth term. And this is a concept that is widely used when you are given summation of terms in a series. Let's quickly do that. N plus 1, n and n plus 2 is common. So I'll take n plus 1, n plus 2 by 8 out when I'm doing the subtraction. And what I'm left with in the bracket is n plus 3 minus n minus 1, which is going to give you n into n plus 1 into n plus 2 by 8 into 2, which is going to give you n into n plus 1 into n plus 2 by 4. This is going to be my Tn. Now, since we want the reverse, we will simply write this as 4 by n plus 1, n plus 2, summation n varies from 1 to infinity as the limit is tending to infinity. And then all we have to do is split this into its respective partial fractions and the question will be solved. Let's quickly do that, right? We have 4 by n plus 1, n plus 2 summation. So I can write this as a by n plus b by n plus 1 plus c by n plus 2, which is going to give you a into n square plus 3n plus 2 plus b into n square plus 2n plus c into n square plus n by the product of these three is equal to 4 by the product. So that will give you a plus b plus c is 0 because there is no n square term. 3a plus 2b plus c is 0 again because there is no n term. 2a plus there is no constant term plus 0 is equal to 4. So from here I will get a is equal to 2 and then I have b plus c is equal to minus 2 and 2b plus c is equal to minus 6. So if I subtract this, I have b is equal to minus 4 and when I plug that back in, I'll get c is equal to 2. So the partial fractions are 2 by n minus 4 by n plus 1 plus 2 by n plus 2. And this is the summation I want as n varies from 1 to infinity. So let's write every term, right? 2 minus 4 by 3 plus 2 by 3. When I put n is equal to 1 plus 2 by 2 minus 4 by, sorry, this is 4 by 2, 4 by 3 plus 2 by 4 plus 2 by 3 minus 4 by 4 plus 2 by 5 plus 2 by 4 minus 4 by 5 plus 2 by 6 and so on. Let's try and observing if there is any pattern that we can spot here. 2 minus 2 by 2 minus 2 by 2, 2 by 3 minus 2 by 4 So all the diagonal terms, as you can see, keep getting cancelled out, and what I am eventually left with are only these terms, because if I look at these three terms, they get cancelled out. If I look at these three terms, they get cancelled out. If I look at these three terms, they will get cancelled out. And as n goes to infinity, the last term becomes smaller and smaller. So the only part that I'm left with are these terms, which is 2 minus 2 by 2, and hence the answer to this question is 1. A very interesting question on first understanding how we can find the nth term when summation of terms is given. Second, a very different partial fractions question. And third, observing the patterns to help you solve the question better. Alright, after that question, let's look at this simple question. Now, sometimes when we look at summation type questions, we get scared and we leave them for later. But we might be doing injustice and leaving some sitter of questions. Let's look at how this can be solved. It's a triple summation. K ranges from 1 to j, j equals to 1 to I, and I ranges from 1 to n. Now, for example, if I is 5, then j, the summation of j will go from 1 to 5, but for each j, k will again be summed. So let's see how this can be done. Let's start by solving the inside summation first. When k ranges from 1 to j, and when I add 1 j times, this inside summation is going to be nothing but j. And now I have j equals to 1 to I is my second summation, which is nothing but the sum of the first I natural numbers, which is equal to I into I plus 1 by 2. So the entire question boils down to summation I equals to 1 to n, half, I can take the half outside, I square plus I, which is equal to half into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 by 2. And again, if I take n into n plus 1 by 2 common, I will get this as half into 2n plus 1 by 6 plus 3 by 6 into n plus 1, which is equal to n into n plus 1 into n plus 2 by 6, and that is my answer. The way I have simplified it is 2n plus 1 plus 3 is 2n plus 4. I have taken a 2 common from that and cancelled it with this. So I'll get an n plus 2 term left, and that is the answer to this question. Now, these mental calculations to save steps is something that we as students need to develop practice for, so that we are able to save time that might be precious and help us solve some other question in the future. Alright, this is one of my favorite questions. Very logical, very fundamental, An amazing question that will guarantee you goosebumps. If A1, A2, A3, so on up to AN are n distinct natural numbers such that each number is not divisible by any prime number greater than 5. So when I'm saying greater than 5, I am saying that each number is divisible only by 2, 3 or 5. It can be any of the three, all of the three, or in any combination. Then what is the maximum value of summation 1 by AI? Now when I look at this question, when I saw this question for the first time, right, we have a summation 1 by AI, great, given that they are distinct natural numbers, excellent, which means all the numbers are positive. Let's do AM greater than or equal to, you can also take QM or RMS, however you want to call it, GM greater than or equal to HM, and now HM has this summation 1 by AI, but the harmonic mean is n by summation 1 by AI. Let's say this is greater than or equal to GM, right? What happens is, if I throw this denominator to the other side, I will get summation 1 by AI is greater than or equal to n by GM. We are not supposed to find the minimum value because this is going to give you the minimum value. We are supposed to find the maximum value. How does one do that? Think about this question for a couple of minutes and then come back to me for the solution. Alright, now we can say that each of AI can be written as 2 power A, 3 power B, 5 power C, where A, B and C are whole numbers, right? There is no criteria that any of these numbers can't be 1 as well. It can be 1 because they are distinct natural numbers, not divisible by any prime number greater than 5. So 1 is also satisfied. Now A, B and C belong to whole numbers, right? Now 1 by AI will be equal to 1 by 2 power A, 3 power B, 5 power C, where again A, B, C belong to whole numbers, right? The trick here is, what we are trying to say is that the summation of this, where this condition and criteria is satisfied, is less than or equal to 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus so on up to infinity. 1 plus 1 by 3 plus 1 by 3 square plus 1 by 3 cube plus so on up to infinity. 1 plus 1 by 5 plus 1 by 5 square plus so on up to infinity. How did I write that? Let's think about this for a certain second. I have finite number of terms in this case, right? But if I take any term from these three brackets, and since it is a multiplication of each bracket, I need to choose one term from here, one term from here, and one term from here. Let us say I choose this term, and this term, right? When I multiply that, I will get 1 by 2 into 1 by 3 square into 1. Now this is a term that satisfies, is one of the AIs in this. Let's take another thing. Let's take this one, and this one. 1 by 2 cubed, 1 by 3, 1 by 5. Now this is another term distinct from the previous one that is a part of my AI. And that is why I am saying that this is the maximum value, because I have considered every possible term up to infinity. And since this is a finite number, this covers the entire universe, and this is any subset of this universe. And this becomes nothing but summation of infinite GP, which can be very easily solved. a by 1 minus r is the formula. So the first sum is 1 by 1 minus half. The second sum is 1 by 1 minus 1 by 3. And the third sum is 1 by 1 minus 1 by 5, which is going to give you 2. And this is going to give you 3 by 2. And this is going to give you 5 by 4. So the answer is 15 by 4. And that's how this question is solved in a very simple and a mind-blowing solution. Alright, let's look at one more question based on summation of terms, where the equation is given in terms of Sn and Tn, where Tn is the nth term of the series. We are asked what T2 square is. Like we did previously, we can actually do the difference of the terms. We can say that Sn minus 1 is Tn, but when I take Sn minus 1 in this case, I am going to get Tn minus 1, and when I do Tn minus 1, it's the, I don't know if it is an AP, so it may or may not be a common difference. More importantly, there are squares. So this is a very complex looking problem if we had to apply the same concept. Never mind there, because if n is 1, then Sn is equal to Tn for n equal to 1, right? Because Sn is the sum of the first n terms, Tn is the term. If n is 1, then S1 is nothing but T1. Let me just simply put 1. So I will get 3T1 is T1 square plus 3T1 minus 2. So now this will give you T1 square minus 2 is 0. So this will give you T1 is plus or minus root 2, right? Let me now put n equal to 2. So I will get 3s2 is T2 square plus 3T2 minus 2, which is equal to 3 into T1 plus T2 is equal to T2 square plus 3T2 minus 2, and this is going to give you, depending on the value of T1, I am going to get the value of T2. Let's simplify this question by stating that Tn is greater than or equal to 0, where each term is positive. So by that definition, I will ignore minus root 2, and I have T2 is equal to T2 square plus 3T2 minus 2 minus 3 root 2. So again this gets cancelled, and I have T2 is equal to 2 plus 3 root 2 to the power 1 by 2. And since it's asking the square, it is equal to 2 plus 3 root 2 is T2 square. Now, if that condition was not given, and since it is a square, it would actually have been 2 plus or minus 3 root 2 would be an answer to this. Depending on whether it's a multiple choice answer or a single choice answer, there should be some additional information provided to us to be able to solve this question further. I hope you loved. Oh, there's one more question. Now it's given that x1, x2, x3, so on up to x50 have a property that for each k, let's say k equal to 5, x5 is k less than the sum of the other numbers, x1 plus x2 plus x3 plus x4 plus x6 plus so on up to x50, apart from x5 minus 5. So each term this is satisfied. We have to find what 96 into x20 is. It's a very simple question when you think about it. Now, if this is the equation, right? Now, if I add x5 on both the sides, I will get 2x5 is s, where s is the sum of all the 50 terms because I've added x5 on both the sides, minus 5. So, x5 is going to be s by 2 minus 5 by 2. If I generalize this, I will get xk is equal to s by 2 minus k by 2. And clearly, this is an arithmetic series because it is linearly dependent on the position of the term, and the common difference in this case is minus half. The common difference is multiplied with the position. We have to find what x20 is. So, for that to happen, we first need to find what s is. S is equal to n by 2 into x1 plus xn. And since we know that there are 50 terms, s is equal to 50 by 2 into x1 plus x50. And using this, what I will get is s is equal to 25 into s by 2 minus 1 by 2 plus s by 2 minus 50 by 2. So this is going to be s is equal to 25 into s minus 51 by 2. So this will give you 25 into 51 by 2 is equal to 24s, or s is equal to 25 into 51 by 2 into 24. And when I simplify this, I can simply find the value of any of these terms that I would want to find. And that's how this question will be solved. I hope you found these questions interesting and challenging. If you did, please do recommend our channel to your friends and family, and do like, share and subscribe.